My name is Aishwarya. I'm a first year BTech student. This PPT was actually a part of my assignment, so I thought it would be useful enough to upload in YouTube. So I have solved around 9 sums in this session based on sinusoids and phasors. I have taken these sums from the book named Fundamentals of Electrical Circuits by Arthur Beiser. This book is actually the 5th edition, which I have used. So the first sum is that a voltage source of V of t is equal to 100 cos 60t plus 20 degree phasor angle is applied to a parallel combination of a capacitor and a resistor. The resistor has a value of 40 kilo ohms and the capacitor has a value of 50 microfarad. We are supposed to find the steady state currents through the capacitor and the resistor. Since it's a parallel combination circuit, the voltage across the capacitor and the resistor is going to be equal to the voltage source, which is equal to 100 cos 60t plus 20 degree, which can also be written in polar form as 100 with a phasor angle of 20 degree. Now, the capacitance value can be found using the formula 1 by j omega c, where omega is equal to 60 and c is equal to 15 to 10 power minus 6. Substituting these values, we get minus 3333.3 G. Here, minus and the J component implies minus 90 degree. So the capacitance value written in polar form is 3333.3 with a phasor angle of minus 90 degree. Now, resistance can be written as 40,000 with a phasor angle of 0. Now, the current through the capacitor is given by the formula voltage by the capacitance, which is equal to 100 with a phase angle of 20 degree by 3333.3 with a phasor angle of minus 90 degree. It gives a value of 300 cos 60t plus 130 degree milliampere. Similarly, the current through the resistor can be found using the formula V by R, where R is the resistance, which gives the value 2.5 with a phasor angle of 20 degree. In the second question, we are just given with a simple RLC series circuit where capacitor value is given as 5 millifarad and inductor value is given as 240 millihenry and the resistor value is given as 80 ohms. We are supposed to find the total impedance and find the current by dividing voltage by impedance. Since all these are in series, we are just supposed to add all the capacitance, inductance and resistance value. Resistance is equal to 80 ohms. And then inductance value can be found using j omega L, which is equal to 0.48 J. And then the capacitance value can be written as 1 by j omega C, which is equal to minus 100 J. Now the total impedance is the sum of the impedance, capacitance and the resistance, which is equal to 80 minus 99.52 J. When we convert this into polar coordinates, we get 127.69 with a polar angle of minus 51.206 degree. So therefore current is equal to voltage by impedance, which is equal to 10, as you know, the voltage source is given as 10 cos 2t. There is no phasor angle over here, so voltage is equal to 10 with a phasor angle of 0 degree by impedance, which is equal to 127.69 with a phasor angle of minus 51.206 degree. So we get an answer of 0.0783 with a phasor angle of 51.206 degree. So therefore, I of t is equal to 78.3 cos 2t plus 51.206 degree milliampere. The third problem is to develop a circuit with a resistor and inductor to find the phasor relationship for the circuit. Here, I have taken a resistor with a value of 4 ohms, inductor with an inductance of 2J. Here 2J implies 2 with a phasor angle of 90 degree. As we know, the reactance or the impedance is the sum of the resistance and the inductance. So impedance is equal to 4 plus 2J, which is converted into a phasor value, polar value as 4.47 with a phasor angle of 26.56 degree. Now the current through the circuit can be found using the formula I is equal to V by J. V by Z, which is equal to 20 with a phasor angle of 30 by 4.47 with a phasor angle of 26.56, which gives a value of 4.47 with a phasor angle of 3.4 degree. Now our main aim is to find the voltage across the inductor and the resistor. For that, So that is why we require the I component. To find the voltage across the resistor, we multiply the current through with the resistor, which gives the value of 17.88 with a phasor angle of 3.4 degree. And to find the voltage across the inductor, we multiply the current with the inductance, which is equal to 8.94 with a phasor angle of 93.4. By comparing the voltage across the resistor and the inductor, we find that the inductor value is 90 degree more greater than the resistor. Thus, the inductor leads the resistor by 90 degree in voltage conditions. Therefore, VL leads VR by 90 degree, whereas the I of T is the current is same for both the elements. In the next sum, we are given with an RL circuit connected to a 110 volt AC source. Here, they have given the voltage across the resistor is 85 volt. Now we are supposed to find the voltage across the inductor. Now, in the previous sum, we had learned that the voltage across the inductor leads the voltage across the resistor by an angle 90 degree. Thus, by Pythagoras theorem, we can state that V square is equal to VL square plus VR square, which gives V is equal to root of VL square plus VR square. Now we are supposed to find the voltage across the inductor. So we can find VL is equal to root of V square minus VR square, which is equal to 110 square minus 85 the whole square, which is equal to 89.82 volt. Now in this sum, we are given with a simple RLC circuit. They have given us that V0 is equal to 0. Now if we know that the V0 is equal to 0, this whole circuit becomes selective circuit. Selective circuit means XC is equal to XL. That is, J omega L is equal to 1 by J omega C, which is equal to capacitance is equal to inductance. From this, we can write that omega L is equal to 1 by J square omega C. So therefore, omega square is equal to 1 by LC. Now, omega is equal to 1 by root of LC. We're substituting the values of L and C, which is nothing but 20 into 10 power minus 3 and 5 into 10 power minus 3. We get the answer 1 by root of 10 power minus 2. So we get omega as 100 radians per second.